Today we're going to look at something called power functions and radical form. So for the warm-up, a biologist is researching a new antibiotic-resistant bacteria. At time t equals 0 hours, she puts 20 bacteria into what she has determined to be a favorable growth medium. 6 hours later, she measures 100 bacteria. Assume exponential growth and use the A equals PE to the RT formula. So first step is figure out what is the rate. So when you see a word problem, you should underline the important information. So at the starting time, she has 20 bacteria. 6 hours later, she measures 100 bacteria. All right, so we have A equals P E to the RT. Plug in what we know. We know that at some time she has 100 bacteria. The starting value is 20. And we need to figure out the rate. And she had 100 bacteria after 6 hours. So we're going to plug in everything that we know, and we're going to use the natural log to solve for our rate. So first step is to get rid of this 20 right here. And we have 5 equals e to the r times 6 power. And then we know that this is a logarithm. Log base e is ln. So we can log both sides. We're going to say ln of 5 equals 6r. So again, the steps behind that, I would have 5 equals log base e of r times 6. And then this, if I log this side, I can log this side. This is the natural log, so this would cancel. So we have ln of 5 equals 6r, and then we're going to divide each side by 6. So let's type that into our calculator. So we have natural log of 5, and then divide by 6. Okay, so here's our rate, 0.26. And with the natural log, this number can be less than 1 and still represent growth. And we can check our answer by plugging in. So if we plug in this side of the equation, 20e to the, and then put our answer times 6, we should get 100. So let's check. So 20e, oops, not natural log, and to the rate, so instead of typing in the whole rate, I'm going to use my answer key to get that whole decimal in there, and then times 6. And we get 100, so we can check our answer. So here, the growth rate's 26%, so R is 0.26 if I round, 26824. After 8 hours, how many bacteria are present? So let's plug in A equals 20, E, and we'll put our rate 0.26824 times 8. So we have 20e, and now I have to type in our rate because it's not the answer anymore. And we get about 170.99, so I'll round to about 171 bacteria. Okay, today we're going to look at power functions in radical form. So I just did a bunch of examples. On the left-hand side, everything on the left-hand side is an exponential function, and everything on the right-hand side is something called a power function. So take a look at them and think about what you notice and what you wonder about power and exponential functions. If you notice, all exponential functions, the exponent is x for all of these. And in a power function, the exponent is a number. So we take a look at all these numbers. And the base is x. So again, an exponential function, the exponent is x. In a power function, the base is x. So we're going to take a look at a power function versus an exponential function. Again, look at where the x is. Here x is the base. Here x is the exponent. So I'm going to write that here. So x is the base, and b, which is any number, is the exponent. And in an exponential function, b is the base, and b is any number. And x is the exponent. And for both of these, a is your starting value. Okay, so we're going to take a look at our graphing calculator and graph y equals x to the 1/2 power. My exponent didn't show up too great, but this is x to the 1/2 power. Let's graph this and see what it looks like. So if I open a new graph page, so we have x to the power of 1/2. Okay, and this looks very similar to a function that we've already done before. And it says, look at the graph, does it look familiar to you? Yes, it does. It looks like the square root of x. So let's try it, square root of x. You see it's the same graph. So we're going to say yes, it looks like the square root of x. So our conjecture here is that they're the same thing. So we have x to the 1/2 is the same as the square root of x. Okay, so today we're going to look at radical form versus exponent form. Radical form has this square root sign, and exponent form has an exponent. So I'm just going to write a bunch of examples. The square root is the most common radical form, so square root of x, so this is x to the 1/2. So if you have a 2 on the bottom, that 2 is kind of invisible right here, and they won't put it because it's the most common root. But if we have something like this, x to the 3/4, I can write that as x, and my radical sign, the 4 is going to go on the outside, and the 3 is going to go on the inside. Let's do another one. If I have x to the, 7/6, to write it in radical form, it's going to be your radical sign. The 6, the bottom number goes on the outside, and then the top number goes on the inside. Let's do one more. Let's do x to the, 2/3. So this one, again, we have a radical sign. The bottom number goes on the outside, and then the top number goes on the inside as an exponent. So these mean the same thing. So we're going to go over how to convert, and then we'll go over why are we doing this. So to convert, rewrite as a radical, this would be our radical sign. The 4 goes on the outside, a to the 3rd. Here the 7 goes on the outside, b to the 12th. Here the n goes on the outside, a to the m. Let's go the other way, rewrite as a power. This will be x to the 3/5 power. This will be y to the 3/2 power. So again, if there's an invisible number in front of a square, it's a 2. And this will be to the 11/7 power. Okay, so these are called rational exponents. A rational number is any number that can be written as a quotient, p over q, so a fraction, where p and q are integers, positive and negative whole numbers, and q is net zero. So here's the thought process behind simplifying rational exponents. Keyword, think factors of. Okay, so what is 10 to the 4th? That is 10 times 10 times 10 times 10. What's 2 to the 3rd? That's 2 times 2 times 2. And 6 squared is 6 times 6. But when we have 10 to the 1/2, actually I'm going to switch this. Let's make this 100 to the 1/2. This will be easier. So let's first of all, think of factors of 100. That would be 10 times 10. And then if I want half of those factors, the answer is 10. And what we looked at today is, this is the square root of 100, and 10 times 10 is 100, so this answer is 10. Let's do this one, 1,000 to the 1/3. So this will be 10 times 10 times 10, and I want 1/3 of those factors. So again, here our answer is 10. So if you try on your calculator, the cubed root of 1,000, you will get 10. Let's try the next one, 16 to the 1/2 power. Think of factors of 16. And if it's 16 to the 1/2, one of those factors is 4. This is the same as the square root of 16, which is 4. Okay. So the reason why we convert to radical equations or power functions is so that we can solve. And so here is how you solve a radical function. First step, rewrite as a power. So this is x to the 1/3 power equals 12. To get rid of the 1/3 power, we're going to multiply that by its reciprocal. So we are going to take this to the third power. We know that a power to a power, you multiply it, and 1/3 times 3 is 1. So what we do on one side, we're going to do on the other side. And to solve this, again, this would cancel to 1. So we get x equals 12 to the third power, which if I type in my calculator, 12 to the power of 3 is 1728. You can check your answer by doing the cubed root of 1728, so let's try that. So here's what we can use, the cubed root of 1728, and we'll get 12. Let's try the next one, rewrite it. This is x to the 3/4 power equals 7. How do you get rid of the 3/4? Well, we take it to the power of 4/3 because we'd multiply those and those would cancel. So we'll take this to the 4/3 power. In our calculator, we type in 7 to the power of 4/3. And we get about 13.39. So 14 or 13. 13.39. I'll round to 4. And let's try the next one. I'm going to take a screenshot of these last two. Okay, so this next one, this is 2 over x to the 3/2 power equals 16. I'm going to cross multiply. I don't want this fraction on the bottom, so I'm going to cross multiply. I got 16x to the 3/2 equals 2. Divide each side by 16. We have x to the 3/2 equals 2 over 16, which is 1/8. And then to get rid of the 3/2, take it to the power of 2/3, the reciprocal power. So in my calculator, I'll type in parentheses 1 divided by 8 to the power of 2/3. And we'll get our answer, which is 1/4. So x equals 1/4. And again, if we type this in, we should get 16 for an answer. So let's try that. Let's do 2. Whoops. So I'll do 2 divided by, and we'll use this right here. This was 2. This was 0.25 I'll put for 1/4 to the power of 3. We should get 16. And we do. Okay, last one. This is x, and if there's not an exponent, it's a 1 here on the inside. X to the 1/4 minus 2 equals 1. Add 2 to each side. X to the 1/4 equals 3. To get rid of the 1/4 power, take it to the 4th power. So x equals, let's do 3 to the 4th power, 81. So here, x is 81. Again, you can plug in your answer and check. So today we looked at power functions. You should be able to switch from radical form to exponential form, and then also solve equations using this.